multicollinearity in R. Now, in multicollinearity in our regression model is what is violation of it is violation of one of the assumptions of the classical linear model. Once one of the assumption of the classical linear regression model is violated, it leads to the problem of multicollinearity. Now, one of the assumptions of the classical linear regression models is that the independent variable, in other words, your x variable must not be correlated with each other. In other words, your x1 variable should not have influence on your x2 variable. Now, the assumption says that there should be no exact multicollinearity among your independent variables. In other words, there could be a multicollinearity, but it should not be exact. In other words, the problem of multicollinearity is not the nature or the kind of multicollinearity, but rather the degree of multicollinearity. Now, I have those data sets in this code. When I run this line of code, it imports this data set into R. It imports this particular data set into R. Import the particular data set into R. And this is my data set. Now, this talks about the sales of cars. And I'm only interested in the sales of the cars, the type of cars, the engine size, and represented by this, and also the fuel capacity represented by the MPG. So those are my variables of interest. Now, once you run that line of code, that imports the data set into our, or you run this line of code using the XLXX function, or otherwise, now since I have more than one columns, more than one variables in my data set, I'm only interested in those 4 variables. So I make use of the pipe function. I selected this variable. I run that. When I selected that variable and I run that using the pipe function, so my variables now is this. So I save it in an object known as this. So once we go to this, you can see now I only have 4 variables. I only have 4 variables. 1, 2, 3, 4. Okay, those are my variables of interest. Now I want to check if there is multicollinearity in among my data set. In other words, if the independent variables are correlated with each other. So what I'm going to do now is this. I'm going to install this package known as lmtext that helps you to run the regression. Then I run this line of code to run the regression. Then I run this other line of code that gives me the estimate of each. If I want to see the summing statistics of each, the coefficients and the rest of that, that gives me that once I run this particular line of code. So alternatively, I could include the formula here and use equals to. Yeah. So once I run this line of code, it will still arrive at the same result. So once I run this, I run at the same result. Once I run this, I get to the same result. Now, or alternatively, I could decide to use the period. So I could decide, since I've already had this, I could decide to just remove all this and replace it with a period. So I run this line of code, and that runs that, and I run this. See, I have to replace it with this. Okay. So that gives me that alternative. Now, if I want to check if there is multicollinearity in my data set, then I have to install the performance package. So install packages and this package. I have to install the performance. All I need is to run this particular line of code. Then I use the library function to pass that into the library function. I run the start activities. I already have that installed in my I. I already have that installed in my I. So I have that installed in my I. So the next thing I need to do is to now run this line of code. Now, in order to run it, let's see the performance, and let's see. I don't know why it's giving me this. Now, that was okay. In order to run the population analysis, we have to use the function, one of the function known as check more auto correlation. I don't know why this is giving me this issue. Check we can see check. Then check for the collinearity. Now, we want to check if there is a multicollinearity in our data set. And this is a model. All what to do is you have to copy and paste here. Then when you copy and paste, you run this line of code. That gives you the variance inflation factor. Now, the rule of thumb is this. A variance inflation factor of 2 and above indicates that there is a multicollinearity in your dataset. Now, in this particular case, based on this value, the variance inflation factor is less than 2. That means our model does not have the problem of multicollinearity. It's free from the problem of multicollinearity. Then this is the tolerance factor. To get the tolerance factor is 1 all over the variance inflation factor. For instance, 1 all over this value will give me the tolerance factor. So that will give me 0.7. So the tolerance factor, a value of the tolerance factor that is closer to 0 indicates the problem of multicollinearity in our dataset. Now you can see our tolerance factor is closer to 1 and not 0. That also indicates that our model is free from the problem of multicollinearity. So the variance inflation factor and the tolerance factor shows that our model is free from the problem of multicollinearity. So also alternatively, we can also use multicollinearity. Yes, it's the same result. So we can use either of this function to check if there is multicollinearity in our data set. Then if we want to visualize the multicollinearity, we could use the plot function. We run this. We will run that line of code that gives us the plot function. Now you can see that there is green. And that tells that there is no problem of multicollinearity. If there is a problem with multicollinearity, then it would have indicated red, and the red tells is an alert telling that there is a problem, that there is a danger, that there is a problem of multipolarity in your dataset. So this is how to check multipolarity in our dataset in